think.
Hello.
I think we're back.
Hi, everybody. That looks a little bit better on my screen.
It does. For some reason, Chrome is
Well, I really
not.
appreciate everybody bearing with us.
Yes.
And when I say everybody, I mean, the true friends.
Yeah, our true friends who put up with what it is that we're doing here, whatever that is. All right. Why is
That's not
okay?
bad.
So,
Yeah, that looked pretty good.
are you watching the stream?
I don't have any audio going,
What do you
but
see?
I see black screen on the side, and I see you and me,
All
and
right.
you and I don't look super choppy. There, I see code.
See code. Interesting. Oh, I know why it renamed the stinking. It renamed my browser window. That's on me.
I will also say that the Zoom is not quite functional.
The zoom's not quite functional.
Yeah, all I see is a white screen. Like I see the
Yes,
camera in Zoom, but
that was on me. That's on
okay.
me. I was thinking that had something to do with the. There we go. That should fix
Hey, there
Zoom.
I see it.
This should fix stream. We should be golden right now. All right. Okay. Hard start. Welcome everyone. we're we're as organized as I think we're going to be in this iteration of OCI After Dark. Thank you for joining us. Um, this is officially our first attempt at this. Unofficially, our second attempt.
Yeah, if you couldn't tell, we've had some technical difficulties. We forgot to click the box that said, "Hey, you should create videos and record them and publish them of our previous stream." So we will reference the night that allegedly happened, and we will talk about some of the things that we built, and we're going to start to build on it. But hey, man, happy Friday! It's
Yes.
another week. It's been a long one. I don't know about you.
Oh man. I mean, you and I have talked throughout the week. It's just felt crazy long. It's felt crazy long to me. I'm glad it's finally over. Well, over,
Tell me
almost
about
over.
it.
We're here. We made it out the other side in
Looks
time.
like we made it. Sorry, I randomly burst into song and
Uh oh.
90s references, but I think
And we got a
we've talked.
copyright strike on our first video right there.
Man, no, that was so off key. It's fine. Nobody would even recognize it. Plus, like Creative Commons, like I don't know, who knows? Parody license, whatever.
Parody that I think that would fall under parody license definitely.
Yeah, this would be another time to mention that the opinions and bad impressions referenced by either of us during this podcast or stream or whatever it is we're going to call this um, reflect our own personal opinions and not those of our employer, who, by the
Yes.
way, is Oracle, which is one of the reasons we're here talking about OCI or Oracle Cloud.
Yeah. So I mean, while we're on that, I know we kind of did soft introductions last time. Do you want to kind of go through that just for preserved history's sake again, just as
Oh, we're
who
not
we
going to
are
make
and
the
what we
audience
do?
guess. We're not going to make people guess who we are. I
Oh
think I
yeah.
thought that was what we talked about. No, yeah, absolutely. So, there's two of us. I'll give myself a bit of an intro, and then I'll let you take care of yours. Um, so my name is Creighton Swank. I work as a distinguished cloud architect on the CTO team at Oracle. And what that really means is, I'm accountable for kind of talking to Oracle customers, trying to build strategic relationships as we start to migrate workloads to the cloud. And really, at the end of the day, it's about education and empowerment of our customers to try and teach them, one, about the features that we have, but also two, you know, you and I both, Jeremy, I know, have kind of a diverse background with other cloud providers and maybe some on-premise technologies. So, I think this is kind of as beneficial for us as it is for the folks that are, going to be watching these videos as they go down in the annals of history. So, I think what we're really trying to do is kind of provide a little bit of, primer to OCI, take a very iterative approach and just kind of show the capabilities of the technology platform, and kind of let you guys watch us learn on the fly. But yeah, I have been in the manufacturing industry my entire life. Since I graduated high school, I've done a lot of different technology jobs from, Windows server admin until I saw the light and really moved towards kind of a Linux administration role. Did that for a number of years. Again, for a manufacturing company, I've done some incident management, so break fix kind of stuff. Kind of IT crisis management, I used to call it. And then I got into architecture, doing some data center design migrations, and then sort of fell into the cloud. Did AWS for a number of years, worked for Amazon briefly, and now I'm at Oracle and learning a whole new technology stack. And so it's super exciting.
Yes. Yeah, yeah. And that's, I mean, you can almost copy paste a large portion of what Creighton said, and that applies to me as well. I don't have the extensive networking and on-prem experience that he does. I started out life as a software developer and kind of evolved into the operations and cloud organically. My name is Jeremy Walker. I also am in the CTO org at Oracle. And our roles there are interesting and evolving are two words that I would say. And a lot of it has to do with informing our customers, mainly enterprise customers, also any new cloud native customers as well, that what OCI has to offer. The cloud platform that I think is the most underpopularized, underappreciated, maybe. I don't know, but it's something that even when I came back, or I came into OCI, I didn't have a really good grasp of what it was, what the capabilities are. I spent a lot of time not opposing OCI, but supporting other platforms, and I had kind of a swayed, biased view against Oracle in general, and then OCI as a platform. And then once I started delving in, I became a part of the ecosystem. Like you Creighton mentioned, it got super interesting learning this new technology stack and seeing the parity, the feature parity between what OCI has to offer and the other major cloud providers. And I think that's something that we would like to highlight here, and then kind of learn as we go as well, because I'm still in that learning phase, discovering new things about this technology, good and bad, and we'll highlight both as we go through this, and then from there we'll all learn together.
Yeah, and you will occasionally see us bring in, teammates or peers or folks who are experts in areas where we're really kind of curious about. So, this isn't an Oracle sponsored podcast or anything like that. We're just kind of streaming and learning, and because we figured that, there's not a whole lot of content out there, especially user generated content for OCI. So I think what we're really trying to do is kind of be more of a just putting it out there. And Jeremy, I've been in tech for a long time. I'm not afraid to fail. So as we start building these things, some of these demos are, potentially going to fall apart as we do it. But, what's a good little good-natured ribbing between friends? I think that's probably a good step in that direction. But, I think
and our hardcore really fans will know from last week that I don't think either one of us are afraid to fail. Or at least afraid maybe, but we're going to fail. The inevitability. That's
Look, I told people all the time in an old role that I was the meat shield. Just get behind me and you'll be fine. So I'm definitely okay with that. But, I think one of the things that we talked about last week in particular was really kind of the foundations of networking within OCI. So we built a demo and it went perfectly. Everything was great. There were no issues at all with it. It was probably the best thing that we've ever done.
Yep. No proof to the otherwise. If anybody.
Yeah, no, absolutely. So what we're going to do is kind of walk through the architecture of what we built, and then we'll kind of show you in the console as well as with some of the code of what we built. But what we really wanted to talk about was kind of getting started in OCI. So, kind of high level, Jeremy, I'm just going to kind of go through this stuff. And if we find that maybe we want to go back and kind of show like tenancy and all that other stuff, then we can, I think it might behoove us to do that. But I don't want to let it stop us from that iteration today. So at the end of the day, what we have is an AWS kind of parallel in the form of an IAM boundary that is not an account. So, I've done AWS for years and years and years. It's not uncommon for AWS organizations to get large, right? So you have a development group, you have various other groups that are all working kind of in the same ecosystem, and the easy way to accomplish that is to give everybody their own account. It prevents sort of development teams from stepping on other business units or lines of business or production operations or things of that nature. So it's really easy to kind of just spin up another account and let everybody go down that path and to kind of sprawl that way. These accounts can kind of move into the hundreds at a time. And one of the really big differences, I think, between OCI and AWS in particular is kind of, we take a bit of a fundamentally different approach. The sort of analogous construct of an AWS account in OCI is a tenancy. And that tenancy inside of it will have compartments. The compartments are a smaller IAM boundary. So what that means is, when you go down the path of essentially provisioning users and allowing them to take actions or build services in your environment, there is a boundary that says, okay, sure, we can do some conditional policies in AWS and do tag-based policies, but at the end of the day, you still have to allow your users to tag. And so savvy developers, I'm not saying that they would, I'm not saying that I've ever done anything like this in the past, but they could very easily apply non-production tags to avoid sort of enforced change control or things like that. That's why the account boundary exists there. In OCI, we have the concept of compartments that really provides a smaller account boundary, and you can allow users and assign policies directly on those compartments that allow you to kind of limit what they can do. So you can have full access inside a compartment to create, modify resources. Yeah, you'll see them kind of pulled out here.
Yep.
And they're
took me a minute. I'm actually logging out. That's the good security about that. I sat here too long and it logged me out. But I'm back in. So I recovered.
Yeah. So this is really super beneficial because I can give someone full access to this OAD compartment, and then they can't touch resources in any other compartment. And so we'll dive into kind of the ins and outs of policy within OCI and all of that, but know that you can set up a single tenancy and still preserve those same sort of boundaries and borders so that you don't have to worry about, one line of business stepping on another line of business.
Yeah.
So that's, I think, really a big difference.
It really does clean up some of the problems that other cloud providers have where, and I know the best practices were to just create different accounts and have basically account factories almost, account vending machines to give to different orgs, different development teams. And what this really does is allows you to keep that organizational structure within a single tenancy for organization, for payment structures, and for security under that same umbrella. So you create, like Creighton, you were saying, create those different pieces for resource management and security, all within that same ecosystem. So you don't have to have all these disparate resources that you then have to manage and regulate and such things. So yeah, it's a really nice thing that, again, something I learned about coming to OCI that I didn't really fully understand.
And again, similar to AWS or Azure or other cloud providers, right? There are multiple regions built out globally. We have presences on just about every major continent, well, except the minor continents. I guess, what is a minor continent? Antarctica is a minor continent. I don't think we have a data center there, but I wouldn't put it past us. We'll get there. Plant the flag. But yeah, so we end up with data centers globally. We end up with sort of a very fast and robust backbone. But it all boils down to customer tenancies. So that is the sort of ecosystem where you would deploy services running in OCI Gen 2. And OCI is, sort of, we've got compute services, we've got a number of things, but kind of the ultimate beginner's guide is you have to have a container to build workloads, right? And when I say a container, I mean you got to have a place to put servers, you got to have a place to put your endpoints or load balancers or whatever component you want to build out in the cloud. So the analogous content to or construct to a VPC in Oracle is called a VCN. And what we did yesterday or last time was build sort of a transitive routing ecosystem, leveraging some of the features of our dynamic routing gateway, which allows you to use sort of a multi-attach architecture to attach a single sort of router construct to multiple VCNs and allow them to share VPN connections to talk to each other or to share that sort of fast connect circuit, which is that dedicated connectivity back to customer premise equipment. Yeah, this is what that looks like. So Jeremy is reading my mind and pulling up this architecture as we speak.
Do my best. Yeah, and so and this is to really go into where we got it. This is available publicly. We can put this in. I'll put this in chat or something. Make this available where this came directly from an Oracle provided architecture. We call it architecture center. It's publicly available reference architecture. The code's available on GitHub. You can deploy it directly into your account from this reference architecture. And something that we're doing, we're going to be hopefully doing a good bit tonight, is take this reference architecture and develop it into something more practical, something closer to a production-esque layout. So we'll start with this ref arc with disparate separated VCNs and turn it into something that has some of the bells and whistles that you would want to see in a real practical implemented architecture.
Yeah, and I think the best part about this is, what we built last week was sort of an island, right? It was the VCNs in OCI. We did not connect any on-premise equipment, although we may do that through VPN in a future installment. But we would use a Bastion server to connect into the DMZ VCN up at the top. And then there were services built in the workload subnets or instances built there. And we would show that sort of lateral connectivity. We would show that ability for those two things to talk to each other. But at the end of the day, those two VCNs aren't connected to each other or aren't connected to on-prem. So the only way to get in is through that Bastion server. So exposing workloads and things requires some iterative development. And I think one of the biggest benefits to OCI is that, we did not invent a new declarative configuration language. We were able to leverage Terraform to do a lot of our programmatic code deployments. So anybody that's got some familiarity with Terraform should be able to get up and running with OCI fairly quickly. And so that, deploy to Oracle Cloud button that Jeremy pointed out earlier really takes you to Resource Manager, which is our, sort of version of a state manager and a web presentation layer for Terraform code. And it will deploy that stack directly in your ecosystem. The other thing you can do is download that template and deploy it yourself. So what I think we're going to do today is really deploy that into or from, a terminal and do it with traditional Terraform commands just to kind of show that avenue.
Yeah, I was going to pull up that, just showing quick what the resource manager looks like, how quickly it is, how easy it is. Quickly is a relative term, as we're finding out right now. But yeah, so if you aren't familiar with OCI's resource manager, it's essentially a managed Terraform interface is what it is. You have Terraform under the covers. It provides an interface to put in variables, parameters, and metadata, and it then executes your Terraform. So that's essentially what this is. You click next through and it will deploy what was, and as Creighton said, there's the backend that's on GitHub. It actually pulls in this Terraform Terraform project, this Terraform repo, and executes it within your OCI, within the compartment that you specify. So then you don't have to manage the state. You don't have to manage the build server, what have you, it does that for you. But
Yeah.
we're gonna do it
But
the
but
fun
if
way.
you've got sort of a rigid CI/CD ecosystem
Hmm.
already, and you're familiar or have maybe Terraform Enterprise where you've got sort of state management, or you already have a process around state management, you can absolutely use Terraform outside of Resource Manager and OCI. And I think that's one of the really big, powerful sort of aspects of it, right? Is you can run Terraform apply, and that same thing can also be deployed through Resource Manager. And I think one of the other things I kind of just wanted to touch on real quick is that
Hmm.
we do have the ability to extract Terraform templates
Oh
from
yeah,
running resources in the console. And we can show some of this later. I don't necessarily want to go
yeah,
too far down that rabbit hole right now, but these are the things I think it's really important to notice. So, Jeremy, if you want to maybe deploy that
right,
reference architecture real quick, and we can just show, or just show that it's deployed with like a plan or something, and then
yeah.
we can kind of just walk through that in the console, and then also just SSH and command line stuff.
Awesome. Yeah, I'll switch over real quick.
Look at these
Should be.
fancy transitions.
I know.
So
Yeah.
cool. Man, look at that. It's almost like the camera moved from one to the other right away. Sorry, he's
Oh,
learning OBS and I'm just being patronizing, which
and
is sort
again.
of my thing.
Oh, and it renamed. Okay, it was gonna be smooth, and it was gonna be, but then apparently everything studio. Oh, it got renamed because I switched the thing over. Come on now. That was gonna be so smooth. I had it all queued up.
Oh, see, I was just looking at Zoom and it was
I,
smooth, so now I feel really bad.
no, boom. There we go. Okay. Apologies for that.
Hey,
Again,
we're still
still learning.
iterating to
Still
success is
learning.
really what
Okay.
it boils down to.
So I'm pulling the bad slash really awesome trick of as I previously prepared beforehand. The redundant statement that is. Uh, I did. What I've done is I actually cloned that repo that we just looked at. I added a few things. I created that compartment that we just looked at, that OAD compartment, and anyone that's familiar with Terraform is familiar with these terms. If you're not, you're able to reference um, existing resources by just pulling down the metadata from them. That's what I'm doing here. So then I can use it as a reference within the code. So I'll pull down this compartment, and so within this OAD compartment that I'm referencing, I'm building out several resources that we saw in that reference architecture. Here's some compute instances that I'm doing just to be able to show what's happening between the VCNs. I'm creating 3 VCNs, one DMZ or public, however you want to call it, and then 2 spokes off of that for a traditional hub and spoke. And then there's a DRG, which is a resource within OCI that connects all. It's if you're familiar with AWS, Transit Gateway comes to mind. It's very similar where you can have disparate networks, different VCNs that can speak to each other locally using route tables and what have you. Creighton being the network genius that he is,
And you
could
keep
explain
you
that a
keep
lot
calling
better.
me that, but I'm just a server guy that pretends is really what it boils down to. But yeah, so I've built out direct connects and things before, and we've worked through sort of the iteration and evolution of sort of the original version of direct connect where you had to have one VIF per VPC, which is very similar to the way that Oracle was up until DRGV2 was released. But the transitive routing really unlocks the power of kind of sharing what you've got and then also making it a lot easier to enable resources as code. So for example, the DRGV2 is really just a routing construct, right? So the VCNs will attach to DRGV2, and then this is all configurable. You can turn this on, you can turn this off, but by default, a new VCN that gets attached to the DRG will automatically have its routes propagated to whatever's on the other end of it, right? So that could be, the fast connect, that could be a VPN, but it makes it really easy to kind of automate the process of spinning up a new VCN, attaching it, and then allowing it to access, any of the sort of hybrid cloud on-prem resources that you may have running in your data center, or, if you're like me, you're a nerd at home and you want to be able to push metrics from your Raspberry Pi. So there's a number of benefits there, but it really sort of abstracts that connectivity construct and makes it so that you don't have to manage the routing within the VCN. You would just need a route in that VCN to the DRG. So that really simplifies pretty much the deployment. So you would build the VCN, you would add the route, you would attach the DRG, and then you're good.
Yeah, and so what you're seeing here is exactly what Creighton was just saying. So this is the DRG resource within Terraform, and within that we attached the DMZ. We attached VCN1 and VCN2. Very straightforward. And then when you go to the VCNs, you'll look the VCN resource. You create the route table, and you notice exactly, very simply, this is what we'll start working through tonight, and then over the next, as we start building out this environment, we'll get more and more we'll get closer and closer to that production environment. But yeah, so if it's not local, it's going to be pointed directly to that DRG. So and then this subnet itself is the subnet resource that we're constraining our resources to be in this VCN. There's only one of them. Again, not necessarily a production style layout, but again, this is a reference this is pulled from a reference architecture. We're going to start building this out a bit more.
Jeremy, in the console, and I know this is sort of deviating, but in the console, if you've got this built, could you pull up the network visualizer? That may help to kind of see what.
That's a great idea. Yeah, let's look at that, because it's something that we can. Well, yeah. While I'm here, before I click over, I was gonna. So if we do, let me see if this. So let's see what all I built. So yeah, and so this is just what it's doing for. It's the plan itself is going through and making sure I was up to date. There we go. I'm up to date. That's kind of a cheat way of taking a look.
Look at the magical infrastructure as code deployment. Isn't it fantastic?
All right, please transition. I switch tabs. So I know what I should have done, and I'll do it this way next time. I'm learning.
He can be taught.
It doesn't. Chrome changes its name every single time I switch over. And so what happens is it gets lost, and there's probably a much better way to do this. There it is. Done. Transition.
We've got the stream open over here. I'm actually able to make eye contact with myself for a moment. It's kind of weird.
All right, yeah. So you were saying the network visualizer. So this is actually a fairly new add to OCI. Well, this aspect of it, the ability to go as deep. What did I say? How do I spell network?
It's there on the right side. You see it under services, network visualizer.
Boom, right there.
Yep. So this will interrogate the network resources that you have deployed, and it will present you with a kind of a visual map, and then give you kind of clickable links to some of the components that are of value.
Yeah. So what it's doing now is it's actually going out and querying and polling the environment itself, using the SDKs, which you can use the SDKs and the CLI to acquire this information as well. So this is just a way to do it through the console.
So this is a great visual, right? So you see that DRG on the left side is kind of the thing that connects to everything. And so each of these VCNs will then sort of have their own independent routing tables. Again, we point to, each one of them, but if you look, that route table's enumerated right there. You can click on it, and it will actually take you in the console to that route table. And then, we'll look at the route table, and then we can come back. Because you can really just see.
Yeah. I tricked you on that one. Yeah, go ahead.
You did.
It'll pull up.
You got the fake. You went left. Yeah. I went right. So here you can see that the DMZ VCN, the one that's kind of farthest to the right, has the internet gateway called out. So it is the way to get into this environment. Mm-hmm. You don't see anything to the left of the DRG that is like customer premise equipment or anything like that. So this is that sort of island architecture that I was really referring to before. Then you've got the CIDRs identified here atop of each VCN. And then, yeah, you can kind of see all of those components, the subnets. You can, again, click and interrogate these things right from here. It makes it really easy to see these things, which I think is helpful, especially as we look at kind of that reference architecture and the code. This kind of, I think, bridges the gap between the two of them.
Yeah, and this is something that you can, as you get more and more complex with your layout, as you have more. This also show the security aspects and the links, and if you have, like Creighton said, the on-prem connections, it'll show you those routes, the CIDRs, and then you, like you say, interrogate and go deeper and see what the subnet structure is. I think if I go to VCN map, again, this isn't a super complex one, but if I ask it, hey, give me an idea of what this VCN looks like, I think it's going to show me this VCN, and then the subnet that we built. Yeah, there we go. Yeah, so this shows me the routes from. So in this VCN, I have the DMZ subnet, which routes to the IGW, the Internet Gateway, but it also has routes back to the DRG. If it had also routes on-prem or routes to a service gateway, which we'll get into a little bit later, it'll also display those as well. So again, great and good call out on this tool that you can then just figure out what is it we have here.
Yeah, it's kind of nice to see. So again, what we've built out is sort of a single bastion host that's in that DMZ VCN, and then the two spokes have instances in them too. And so we can show real quick those two talking to each other and talking through the DRG to allow that connectivity. But then what we're going to do is really start to get a little bit iterative and start to build out and expand on some of this.
Yeah. Yeah, so let's do that. So let me switch back over. Let's see if this transition works. It didn't.
Oh,
man.
Drat.
So every time, just don't change things. Why is
You just need to have like 17 monitors and make each camera one monitor, and then you're good to go.
Yes, everything its own little thing, which is what what it doesn't like. Yeah, because I switched off of DMZ. It told me, it said, hey, your window name changed. I don't know where it went. Which to me is like, all I did was click on a tab. I don't understand why you freaked out so much.
Well, once this comes back up, I'm probably going to go get more coffee because it's been one of those days and I am out. And just to be clear, while this does look like a whiskey glass, it definitively is cold brew coffee that I've been drinking. Homemade cold brew coffee nonetheless too. DM me for recipes. But oh man.
Wait, so what is your coffee preference? I think
I've been doing a light roast in the mornings. I used to be a dark roast guy. I really did. And I thought I loved it. My wife hated it, so I was like, fine, we'll get like a medium roast. And then I was like, oh no, I like it lighter. And in fact, what I found out is that light roast coffee has more caffeine. And you know, that's the only reason to drink coffee. But I'll do hot coffee in the morning. But I've been taking a lot to cold brew lately, and I think I'm really kind of digging it better. So I think I might make a bit of a more persistent switch. The challenge with cold brew is the first batch I made was like super caffeinated, and I didn't know it. And so when we were streaming last week, by the end of it, I was like, let's go build a house.
That's awesome.
Because I see your code back up in the stream.
Yes, I found it. It was hiding from me. Now what I'm gonna do is, I'm like what you said.
I'm gonna go grab coffee.
Sure that what I built actually works. So I'm gonna go. I'm not gonna show this because I guess I could have shown it and switched back and forth, but because I don't think I changed anything. But what I'm doing is I'm just grabbing my IP. Let's see here, SSH OPC if I remember correctly. Yep, that, and then do dash hi, and then I think think I called it. What did I call it? OA. What are we? What are we? We're at OAD.pem, I believe. If not, I'm gonna have to cheat and go look. Boom. All right, we're in. Where am I at? Hey, it works, and the key works. And Creighton's gone. He didn't even see it. For all y'all that were here last week, this did not work the last time. The first, second, or third, or fourth, or fifth time. But yeah, we're good. So I'm now in that Bastion server, in the DMZ, in our VCN. So what I want to make sure of is that I can get back to servers that are in those kind of hidden VCNs, those private VCNs. That when we looked at the visualizer, there was no route to the internet. There was no route to a gateway. They were all routed through the DRG. And when Creighton gets back, what I want to do is test something that I asked him about earlier that I did not know is how traffic trying to get out is going to be treated going through the DRG. We'll try that. We'll figure that out. And now he's back. Yeah, so
say my name 3 times, I just appear.
First time. Yeah, there we go. It's like Creighton, and yeah, spins out. I forgot what happens when Beetlejuice shows up. All right, so
fun things.
Yeah, fun things. It's been a long time since I saw that movie. So I'm gonna test. Let's just do Spoke 1, the Spoke 1 instance. It's actually.
Did I hear you say you had a test question for me?
I did. I'm gonna hit. So I carried. If you don't know SSH, I carried forward my PIM, so I should be able to go directly into this private. Yes. Okay. So I'm in Spoke 2. I guessed wrong. Yeah. So let's see where I'm at. Yeah. So I'm now. What I was able to do is SSH into the Bastion server in the DMZ, and now I'm in our private VCN that is not publicly accessible directly. So it's a jump box. This is a fairly common construct to develop.
Before, fun fact about that, I'd always called them jump servers my entire life. And then I started working with AWS, and I was like, what's a Bastion? It's like, oh, it's a jump server. So in my head, I will still say Bastion, but it's just word translation.
Yeah, so I'm going to try something. And I think you told me this will not work. But I was it's just interesting. So yeah, I'm guessing it's dead. Because there's no route out that can complete a transaction. And that's because
this subnet's route table is default, yes? Is default 0000 to the DRG.
Yes, okay. That's correct. And we can we're actually looking at it right here. So yep.
I'm looking at code. Okay, so that didn't work. What does the route table look like on the hub VCN that it is attached to?
There we go. So here is this is the route rules for that VCN.
That's for the hub VCN or for the Spoke?
The hub VCN.
Okay, so you have default going to the DRG.
Yep.
So are there 2 subnets in the hub?
We need to call this out. In the documentation there says there is. In the actual code there's not. There's a single subnet.
Interesting. So can we go into the console real quick? This is just me going down a rabbit hole, so I won't take super long. Can we go into the console and then look at the routing table for the hub VCN?
Yep. Let me hide that. Show that. Please work. Come on now. All right. Nope. I've got this down to an art now, though.
Sorry, you see me doing this because I'm looking at the stream and looking.
There we go. All right, so we're gonna go to the. Let's see here. You can search for
in the stream, Jeremy. I'm just seeing. There we go. It just loaded. Sorry.
No, you're good.
Keep see the okay, yeah, you're good.
Yeah, so we'll go to. I'll just crawl down the stack. Make sure I'm in the right. Yeah, so you want to see the DMZ, the hub VCN
Yes, let's look at that because I just want to see subnets inside of it.
Okay. Yep.
So we have one public subnet. Let's click on that subnet and let's look at
Yep.
that route table. I did not water this coffee down. It's still very potent. I had diluted it, but this was not diluted. Oh boy. Okay. So you've got more specific routes for the two attached spokes.
Yep.
So the hub and the spoke know how to talk to each other. And there's only one subnet. So this is like best case, right, to troubleshoot this. So there's only one subnet. The attachment for the IGW is there. So you cannot transitively access the internet through that, which
Okay.
I think was my theory when we were chatting about this earlier.
Right.
But it's good to see that in practice. What you would do if you wanted to do like sort of centralized egress is you would likely need to have a private subnet here. And so the subnets are the routing boundaries, right? So you can have different route tables for each subnet. So what I would do is build a private subnet that has, say, a firewall in it. The firewall would have two VNICs, one that would be on the private subnet, one that would be on the public subnet. The firewall would need to do the NAT, or essentially pass that traffic through to the IGW. And just like in AWS, you need to turn off the source and destination check so the packets don't get dropped.
Right.
That functionality is very similar, but that device would need to do it. So what I think is happening is when you do a connection between the two SSH nodes, you'll see the source IP on spoke 2 of the box in the spoke 1. So the private IP addresses will pass through the DRG from the source and destination. So there's no natting or anything that's happening there. But when you get to that outbound connection, there must be something in the IGW that will drop that traffic if it does not come or initiate from that VCN. So I'll have to do a little bit more digging there. I've got a network guy. Well, you know him, Jan. I think he'd love to come on and chat with us about this stuff too. So we could just pepper him and play Stump the Chump because he's an actual network guy. I just pretend to be one when it works out.
I played one on TV.
Well, apparently, I guess this counts now, right? I haven't had TV service for years, so.
So let's say let's just do that. So if I'm in where am I? Spoke 2. So if I'm in spoke 2 and I want to make I want to be able to ping, or I want to be able to pull updates from a public repo or ping Google for whatever reason. So what you're saying is I need to take the subnet that my box is associated or located in, and then create a route so that public traffic goes to some sort of natting entity. Is that right?
Yep.
Okay.
So you have a default route now that points traffic to the DRG. This is the easiest case, right? So if you're not doing centralized egress, and if you're not going to have some sort of device in the public subnet that is doing that sort of firewall pass traffic out to the internet, then what you have to do is do this within each VCN, right? And the way to do that is to add a NAT gateway. So an internet gateway provides inbound network access, also kind of outbound, but it's primarily designed for inbound traffic. It just so happens to benefit for outbound traffic as well. But the NAT gateway is designed to provide outbound traffic, right? So that's the difference between the two. And this is the same thing in AWS also, where the IGW provides inbound network access and also outbound network access for the things that are attached to it. But the NAT gateway provides outbound network access. Now, unlike AWS in OCI, you don't need to have an internet gateway defined in order to use a NAT gateway. You can just use a NAT gateway. They just exist. But functions basically the same way, where they will essentially allow that traffic to go out. It will have a public IP address associated with it. And then you can just access it without having to have a public address associated with your box. That's the big difference between NAT and IGW, right? We talked about inbound and outbound versus outbound. When you use an IGW, you need to have a public address assigned to you. So that gives you a kind of a one-to-one mapping for that traffic to come in and go out, right?
Okay. That makes sense. Okay. Let me do New share, and let's go back and let's see if we can do that.
So we do need to talk about routing too real quick. So
Okay.
more specific routes will always be preferred. So we talked about that 0000/0 is the destination for the
Right.
route. That is the least specific route you can possibly have. That is the route that will be the abandon all hope, all ye who enter here. Hail Mary, full of grace. We're going to hope that the upstream router knows how to get to this guy. So if you want to still maintain your connectivity to the DRG and the other VCNs, you would need to add routes specifically to those 10 dot spaces on that subnet's routing table. So you would have to be more specific and add a route that goes to the DRG. So instead of that 0000, you'd need to change that to the CIDRs, which I'm assuming we have in a variable somewhere that we can reference. Yep.
Yeah.
And you would need to add another route for.
I'm gonna steal that.
You would actually just need to copy that value. Just copy the var spoco1 VCN CIDR block. And you're modifying spoco2, right?
Yes. Yeah. I'm stealing this from DMZ.
Cool. Yeah. So you'll also need to add a route to the DMZ subnet too. So this is your current route table for spoco2, right? So just modify that.
And then we're gonna add description. Who needs a description?
The network entity ID will be the same.
And so the destination. No, that's not true. Yeah, that's right. Destination.
Yeah, that is.
Yep. And then
So what I would do, Jeremy, is that DRG01. So that route rule, the first route rule that you have with the default on it.
Yep.
Change that to the subnet. To the hub VCN CIDR block, and then basically just copy that route rule block. So you'll need two route rule blocks that each have a 10 dot destination in them, and the network entity ID will be the DRG for both of them.
Okay, so we'll have this ID. So we want to go to the DRG for spoke1 CIDR blocks in a society.
Yep. And then you can basically take that destination in the route rule above you and remove the 0000 and replace it with the variable name for the hub VCN.
Okay. That makes sense.
Because you need routes to both, right?
So I bet, what do you bet we have? What is it called? DMZ? Oh.
So I would assume it is DMZ. No. Well, let's go and look. And this is the fun bit of this stuff, right? We talk about, we use buzzwords like CI/CD all the time. This is CD or CI. We are continuously trying to figure out how to improve this on the fly. Watch the development process happen.
All right, now so this is the one that we're gonna reference something that doesn't exist, right? Because we'll want to reference a gateway.
So what I would do just real quick, honestly, is don't talk about IGW and Spoke 2 yet. Like don't put that in there. Let's get the two. You've got your two route rules in there. Let's just delete that. Let's run a Terraform plan, see what happens, and then we can go look at the change in the console. Right. So the only thing that we did here was add. Well, we removed the default route in Spoke 2's route table, and we added two more specific routes to the 10 dot spaces of the two spokes. Now, we talked about in the beginning that being really easy to spin stuff up. If you have like sort of a contiguous subnet block, so say, for example, you want to have 15 VCNs in OCI. Each one of them would be IP space that sort of came after itself, right? So if you do, CIDR 1, then CIDR 2, then CIDR 3, all carved out of the same block, you can summarize that route. So you could do like a 10.00/8 for all 10 dot space in OCI. And you could point that in there. So you didn't have to manually make route table changes for every single CIDR. This is a small demo environment, so it's easy for us to add two CIDRs. That's no problem.
Okay. So yeah, so it pulled in what we're like we said, it's removing that kind of catch-all, the default, like you said, and then we added this specific. Uh, that's the DMZ cider, and then we're also adding the cider um, for the one spoke.
Yep. And
All right.
so, I think you could also do both of those all at once with 10.0.0.0/8, right? So we could talk about subnetting and all that stuff, but I would need for this to be a much lighter brown color for that discussion to be productive.
Yeah. So let's see. But yeah, so this makes sense. So if this works, then we're gonna go back and we're going to add a NAT gateway to
Yep.
facilitate the.
So let's retest that scenario that we
Yep.
had, right, where we had both of the instances. Once this is done, which it looks like it
Mm-hmm.
is,
Yep.
let's get into it. This is the Bastion server, right?
Yep. So we didn't break that, so that's good.
Cool. So let's try and get into that Spoke 2 VM again. And 1020, is that?
Yeah, 1020
Is that Spoke 2?
is B. Yep.
Okay, cool.
So we're in.
So yeah, we're in. And go ahead and ping or try an SSH to Spoke 1 VM IP.
Yep. Now let me steal that. I should have pulled that IP ahead of time. That would have been.
Hey man, we're doing it live. We're full on Bill O'Reilly
Do
here.
it
It's
live.
cool.
Yep. But hey, already this is going much better than my
I don't know what you're
previous
talking about,
attempts.
man. Last week was perfect. We made no mistakes at all.
Ah, copy and paste did not work. Oh, hey, that's already a good sign.
Cool. Yeah, connectivity's there. If
except-
it's
Oh, I didn't. I know what I didn't do. I didn't persist my the key. Connectivity's there.
Yeah, if it brought up that key fingerprint,
Yep.
then the connectivity's there. I mean, you could ping it to see. I don't know what the security groups look like, but at the end of the day, it's not that big of a deal, right? The
If I do
connectivity is
this-
absolutely there.
And I do that. That works. There you go. Now we're in.
Cool. Yeah. So we still have transitive routing. So before we go back to making some more code changes, let's go look at this routing table again in the console for
Okay.
Spoke 2, just so that we can see the changes.
All right. Yeah. So let's walk through what we should see while I steal this, because I'm
Yeah,
doing
for sure.
my-
So again, the changes that we made, and we're taking a very iterative approach to this, right? So the two changes that we made were we removed the default route from Spoke 2. We did not touch the routing table for Spoke 1. We did not touch the routing table for the hub VCN. Just in Spoke 2, we removed the default route to the DRG, and we replaced that route rule with two route rules that are essentially more specific. So what that means is when a packet leaves the instance on Spoke 2, it will hit the VCN routing table, and it will look at that routing table and say, where do I go? Right. And it'll follow through the more specific routes. We only have /16s here, so these are both the same. They're considered equal weights. But it will look for the destination IP in those routes. And if it finds it, it will take that path. Now, in this case, we're using the DRG. If we want to simplify this even further, Jeremy, we could remove that down to one route rule and put the 10.0.0/8 in there. Now, the thing that you can't see in this route table that Jeremy's showing is the local VCN cider. So these are the ciders for Spoke 2, or for Spoke 1 and for the hub VCN. There is no reference to the Spoke 2 cider in this route table. And the reason for that is the sort of inherent VCN cider for the local VCN that you're originating traffic from, that is always a local route. In the AWS console, you can actually see that route. In the OCI console, you cannot.
Yeah,
but
I was actually going to mention
there.
that. I was so used to seeing it in like an AWS route table listed as that hard-coded default one that when I didn't see it here, it kind of I was like, oh, do I have to explicitly denote that. But no, it's implied in the same way because I
Yep,
think that's
it
pretty
is
standard.
always there. So these two route tables that we're seeing here are essentially the route tables for the destinations for the other spokes, for lack of a better term, because it's not really a hub and spoke architecture. The DRG is actually the hub, right? But we still kind of use the term hub and spoke. But the Bastion VM now has that. Yeah, that's a good point. I'd love to see how the
Yeah,
network visualizer
I got
changes
curious.
this.
I wonder if it shows both of them. We have two routes. Technically, they're going to the same place, but words.
We may
It
not
should
have made
show.
enough of a change. Yeah, we might not have made a significant enough change to show at the macro level, but when you click on Spoke 2's VCN,
Mhm.
you should be able to see like that in that VCN map in particular, you'll see that route.
Yeah. So
Yep.
yeah. So it should show. I don't know what it should show. Yeah, I could see it showing one line with two rules or two
I mean, we
lines.
saw the routes on here before, yeah,
Yeah.
but I
So
don't think they were enumerated
oh,
super
it's
deeply.
one. You click on it and it shows two. So it's not graphically depicted. It shows plus this one plus one. You click on that, and it shows the
Cool.
destination to here, and it shows both of those side ranges.
No,
So
yeah,
good
that's
deal.
fair. So I think the next step, Jeremy, would be to add a NAT gateway to Spoke 2. So let's do that without making any route changes. Let's just add the NAT gateway in code,
Okay. So let's go.
and we can add the route to it too if we want. I just I like iterative, but it's a small route change, so we would point default to it. If we wanted to add it, we would just use that sort of block that we had before, but the cider would be 0000. And so again, that's kind of the final component, right? So when you add the NAT gateway, nothing will use it unless you have a route rule to tell the subnets to use it, to tell the instances on those subnets to use it.
Okay.
So this comes in two forms. You have to build the component, the network entity you're going to route to, and then you have to add a route to it. Now, again, the nice thing here is that the subnet is the routing construct. So the sort of idea of a public and a private subnet exists here as well. A public subnet would have sort of a route to the internet, and a private subnet would not. We only have one subnet defined here, so we're just going to use it, and it's essentially going to be a conversion it's going to be a private subnet, but it'll have a route to a NAT gateway. So we'll be able to reach out and touch things on the internet to do patches and all that stuff. So yeah, I'll leave it up to you, Jeremy, in terms of if you want to add the thing and then deploy it, or add the thing and add a route and deploy it.
Yeah. So what I think we can do is create the resource itself. So we'll create the NAT gateway, and then we'll actually add the associations and then the routes to it, just to kind of step through.
The other thing as you're coding that would be cool to add would be potentially the service gateway.
Yeah, oh yeah, you definitely.
So yeah, so while you're typing there, I'll give a little spiel on both of those things, and
yeah, I'll go through this, and then we'll.
Cool.
You can watch my bad typing, and then we'll.
Yeah.
You can explain.
So Jeremy's going to build the NAT gateway now. This is the thing that allows outbound internet access. So the way that we will make this work is we'll build it, and then we will add a route in OCI to point traffic that's destined for 0000/0 to that NAT gateway. The other thing he's going to build is a service gateway. And we'll show what that route construct looks like in a minute, but essentially the service gateway is a construct that allows Oracle managed public IP space in that region to be sort of injected into your VCN route table. And that way, the more specific route sort of phenomenon works and enables you to essentially privately connect from your VCN to any of the OCI services in that region. Now, there's a couple of analogous components within AWS that make some of this stuff work on their side as well. They have two types of endpoints. There's a gateway endpoint and there's a private link endpoint. The gateway endpoints for Dynamo and S3 both work on the same construct. It's a routing construct. So if you add a gateway endpoint for Dynamo or S3 in your VPC in Amazon, what happens is you'll see a route table entry that gets added that says, essentially the reverse zone for that managed space, and that's an AWS managed prefix list, um, and it'll work in that space. But it's only for those two services. The gateway endpoints are only for Dynamo and S3. The private link endpoints work a little bit differently. They sort of rely on DNS injection. So they'll create private endpoints in your VCN. Those private endpoints can be accessed in one of two ways. You'll get a custom DNS name you can access that way. So, AWS S3 CP, because there is an S3 private link endpoint as well, and pass the endpoint at the end of it in your command line. So dash endpoint equals, and then you use the custom URL for that private link endpoint. Or if you have the local DNS resolver as authoritative, when you do a DNS lookup for something like s3.amazonaws.com, the local VCN resolver will know that you have that private link endpoint and actually just resolve the private IP address for you. So that way your traffic is routed there without having to make like CLI changes or anything like that. In OCI, the service gateway is a routing construct, just like the S3 gateway endpoint, but it can work for either object storage, which is our sort of S3 compatible object storage layer, or for all services in region. So I know I've had some issues in the past managing, sort of custom DNS and a number of other things with private link endpoints. Also, private link endpoints are ENIs. So when they drop into your VPC, you will tend to get one for each availability domain that you're in. And it eats a lot of IP addresses too. So if you're, like a lot of large enterprises that have been doing 10 dots for a long time and maybe didn't have the foresight in the beginning to know that there's going to be a finite and limited resource, you can get into constraints for IP addresses pretty quickly in that space. And so, you'll end up maybe having to sacrifice or not create the right endpoints or all the endpoints, or worse, send all that traffic out the internet gateway, so you get to get billed for internet egress traffic to talk to AWS services. I know this because I've been through this. Having said that, on OCI, I'm not even going to talk about pricing, but at the routing layer, you can use that sort of private VCN endpoint to talk to any of the services, and you really don't even have to manage it because it all works on routing. So the routes, the traffic that leaves your instance will hit that VCN subnet. The VCN will go, oh, I know how to get to this. I'm going to go talk to the OCI, the Oracle Managed Prefix List. And so it becomes a lot easier to manage connectivity to sort of those upstream services without having to get creative with, IP addresses and conditional forwarding DNS rules and, endpoint changes and things of that nature. So I really like that. I really appreciate it. Jeremy, it looks like you've been coding.
Well, I actually I had to click over to yours. I actually stole the service gateway from you. I couldn't remember this off the top.
So this piece is a little hairy. So I was referring to in my sort of overview, object storage or all the services. This is the thing that makes that work. When you specify this in Terraform, when you create it, you're given an option to pick which one you want. And so we're going to give it all services, but you have to get a little creative about parsing that output in Terraform. And this is not necessarily mine. I stole this shamelessly from the internet. So
why can't I think? OCI core. It's amazing how muscle memory takes. You think you have it, and then you have to reprogram everything. All right, there we go. So I think this is the
cool.
Yeah.
So yeah, and this is a very similar sort of construct, right? When you create it, you give it the compartment that you're creating it in. That's a universal variable for a lot of these things, but it doesn't have to be. You can create your network constructs in one compartment, and you can create your compute constructs in another compartment, and you can allow your development users, say, to use the network resources, which is essentially provision instances, but not manage or change network components, right? So you preserve that sort of separation of duties from a security perspective, but you still enable that developer velocity. They can go build whatever they want because all the network components exist and they don't have the rights to change them.
Let's see how well I did. If I can remember.
Well, I was going to say, TF plan, let's do it. Go big or go home, Jeremy.
Uh-oh. And did it again.
Yeah, this is the problem with using the VS Code terminal for SSH access too.
Clear. There we go.
You're on a Mac, so I can't give you my spiel about how awesome MOBA Xterm is.
Oh, don't break. Be happy. No! What happened? What did I do?
I think you should remove the bracketed index to refer to the single instance of this resource. I mean, that's what I would do if I were typing. I say this because you can't hit me from, Alabama, but.
Is that right? Did I do that? Does not allow count. Oh, for okay.
Yeah, I'd have to go look at my code. I know there was some weird parsing that we had to do, so let me call this up. I'm going to use my IDE VI. Sorry, I also have a very clicky keyboard, so I apologize if anybody can hear that. But I also, fun story. This is the keyboard that I had on my desk at work at my last job in the manufacturing industry. The gentleman who took my role also took my keyboard. And COVID, right? He's been working from home, so he's texting me the other night and said that he spilled a bunch of liquid into it. Whole bowl of cereal went right into the keyboard, and he was able to clean it up and plugged it back in, and it's working today. So I am incredibly happy with the folks at DOS Keyboard. Hashtag not a sponsor. I just like the keyboard. Also, there's an off chance he may be listening, so I figured I'd plug it. If so, hi, Ben.
Somebody is going to be watching this and screaming at me. This is what you're supposed to do.
Let's see. So service gateway.
Oh, wait.
There's two components to that. There's the all services, and then there's the service gateway itself. So you got that in there.
Yeah, because we're
There's
not doing
filter.
multiple.
Regex true.
Oh, service does dot. ID. See if that works. That's where copy and paste can get you in trouble. Because I was copying from Creighton's code, and Creighton had his counts lined up because he had some conditions in there. Oh, yep, that's on me. That's on me. Did I do that at the other ID? Okay. Let's try that again.
This is fun. I mean, this is like my idea of fun is just kind of hacking through stuff and solving problems.
Yeah, but see, and this is also why you iterate through it. We were creating the services. Boom. We created the services before we go that far deeper to make sure that, me making the mistakes. All right, so we'll go ahead and do...
And that's really the whole concept of that CI/CD type deployment, right? Is you make way more frequent changes, but you make way smaller changes. And so that sort of ups the quality of your code and your releases as you push these out, right? It's very easy to make a change, commit it, deploy it. Oh, everything's good, cool. Make another change, commit it, deploy it. Everything's good, cool, right? So had we added all of this stuff and built all the route rules and all that other stuff, it could have been challenging to try and track this down, or it would have been at least harder because there's a lot more noise, a lot more ghost in the machine. Oh boy, I was so excited that this was going to work.
What did I? Is it?
What did it not like? Service gateway. Data server. No, that. What's that one reference between 55 and 56? Do you see that? Is it like a break between line 55 and 56?
Oh, it's the ID.
Mm,
Where it's, but it looks
sorry,
like
I'm again a
no,
VI guy, so I'm not used to all this fancy stuff. You have autocomplete and all that crap, and it
46.
just blows my mind. I'm gonna have to sit down with you one of these days and actually figure out how to like do real code. Service ID.
Data source is not valid. Is that wrong? Is core service
I'm
gateway not
looking
right?
line by line. This looks pretty solid.
Is core service gateway? Service
Okay,
gateway.
so actually, I think this is supposed to be. Can you show me where the data source is? Okay, yeah. Okay, sorry. No, you're right. OCI core services, all OCI services. Filter, you've got that right. Service ID, and I've got a lookup around that. I know we removed the lookup, but
yep.
In the resource to go to the data source is values all dot services there, and then in the services, the service ID, there is a lookup. So the service ID is a lookup that goes to the data source that we created above. And I'm going to assume that there's no hierarchical order, like the data doesn't have to be first in the template above the, because Terraform just mashes all this together and evaluates it, right?
I would think. Services.
Somewhere there will be someone watching this video going, "Oh, you idiot."
Yes. That's what will happen. Somebody needs to be out there and be like, "Hey, this is when I switch to the other screen and I start Googling furiously."
So you removed that lookup, right?
Yeah, I removed the lookup. Well, it's still doing it. It's still referencing data core services.
Can you wrap a lookup parenthetical around that? So service ID equals lookup parentheses data and parentheses.
Oh, you mean?
Yeah, the word lookup right before that and then a parenthesis.
Gotcha.
And I know we removed that for a reason, but I think it had to do with a lot of the indexes around it.
Nope, it wants me to do.
Oh, so you're going to look up comma parenthesis ID, or I'm sorry, double quote ID.
Yep.
Yep.
All right. Learning. That's what this is all about. It's like what we said.
Hey, this is Terraform. I'm way over my skis with the functions in Terraform. I can write the code to deploy resources, but the fancy stuff always gets me.
All right.
Okay, so 1 to add, 0 to change, 0 to destroy. Good to go. So some of the OCI network resources will require a rebuild to change. Like I think if we replace the routing table, that may trigger a replace, but it will always tell you, right? That's why you run plan first. What? Oh.
That's where I'm trying to find what is this value actually. What is the core services? Let's look. Core services. Fine. Oh nope. Copy.
Core services. OCI core services. State OCI core services.
This is where a few moments later pops up.
Yeah, this would be nice if we were creating a video and not streaming. That's okay. We'll edit it all out in post. It'll be fun.
Yes, edit in post.
Trying to think if there is a. So there are some more attributes in OCI Core Service Gateway that you seem to be missing. So there's a VCN ID.
Oh, really?
An account for, but that's just to trigger whether or not we want to do it. So, you've got that. Okay,
ID.
sorry. Nope. You're on top of it. And the count doesn't really matter because we're just turning it on. That's whether or not to turn it on. So never mind.
There's the value dot
So,
ID. That's interesting.
Yeah. Well, I mean, we could comment this part out and just look at the NAT
Yeah.
piece for now and come back to this. I don't want to necessarily waste everybody's time, but
Yes. Let's see. There we go. All right. So if I do that, we did create. If I do that, because we did create the NAT gateway. So let's get that incorporated, and we'll figure out what in the world wants us.
okay. So did we add the route into the NAT gateway as well, or just create
We
the
have
resource?
not. Nope. So we need to do that. So here's the route.
Oh, yeah. So this is the route table. We would just add another block right like this.
All right. So
And instead of the
again,
DRG, we're going to use the NAT gateway.
all right. So yeah. So entity ID is going to be OCI core, and then NAT gateway spoke. And it's already got it. Dot ID.
Cool. And then the destination will be 0000.
Yep. So yeah. So
Slash
that's
0.
everything else that Nope, that's the wrong thing. 0.0.0.0 slash 0. And it's a CIDR block. So that should work, right?
Yep. You should be able to deploy this right now.
Make sure I didn't typo things because I am prone to typo things.
Sliders aren't supposed to have 5 zeros. Oh, no, wait, you're good.
All right, so yep, we're changing. It should be. Let me scroll this up so just we can get a good view. Yep. So yeah. So in hey, the update in place. We were wondering about that a bit earlier. So it does look like it updates that record.
Cool.
In place.
Yeah, so we can go look at that in the. This is a plan or an apply.
This is a plan. That was a plan. So we do apply, and I say, yes, I'm sure. When it runs the plan again and then applies, yes. All right, that was quick.
Cool. Yeah, we can head over to the console now and we can look at that route table.
Oh, what happened? There we go. All right, yeah. So I will do order of operations here. That share. That, and then I'm going to go over to here.
Cool. And
let's see. Let me get it.
I'm spoiling it for everyone because you shared it with me first, so
yeah.
I'll shut up.
Yeah, I cheated with Creighton gets the early preview.
I'll just look real bad, sad and dejected. Yeah, this is ultimately
awesome.
the fun part about doing it live, right?
Look at that. And I didn't even hit refresh. That was an auto update on the screen.
Yeah, these pages will auto refresh fairly regularly. I don't know what the interval is, but I think it's like at least 30 seconds or a minute. It's not quick enough, so you end up hitting refresh manually. But so now, when a packet leaves an instance in the Spoke 02, it will go and access the local VCN. So Jeremy, let's try and show that connection to Spoke 2 VM again. And remember earlier when we did the curl to google.com, it failed. Let's try that again.
All right.
After
Yeah.
we make sure, yeah, perfect. Yeah, let's do the virtualization or the visualization here, and then we'll try both of our scenarios again. So let's try and connect to Spoke 01, make sure that still works, and then let's try and curl to the interwebs.
Go.
If you can name that song, I'll be impressed.
Uh, Bangabus, right?
No, come on now. That was
No.
Beastie Boys.
Oh man, no. All right.
Girls.
So hey, look, we have something new.
Hey, look, yay. Now, if you click on that and go to the routing table, that'll take you right back to where it was. So it's not necessarily the most important, but let's click on the VCN map. Let's see what we see.
I need to move this monitor. I feel like I'll look over and I see my profile way too much.
Oh, no. So there we go. So we show the routes going back to the,
Yep.
the DRG. We show the route to the NAT table or the NAT gateway. So yeah, let's connect up.
Ah, yeah, let's do that. Code, view.
You may have just aged out too. I think there's like an hour on the.
There we go. I think we're all on the same
Cool.
page.
Yeah, well, you do that. I'm gonna step away real quick, but I will be right back.
All right, yeah. So I am in now. What I'm gonna do is skip over to VCN2. Man, Creighton left right in a, like we're gonna see if this actually worked. So previously, what would happen was we were trying to call out to the internet, and it just went to the DRG and died because there was no natting enabled. There's no way to get public because it was just a private IP. You can't complete those connections because there's no return IP. There's no return routing. So now we should be able to curl. Let's just do Google. Oh my goodness. Okay, so we got the move thing, which is what happens when you curl it without the HTTPS. But it worked.
Hey, success. That's what we like to hear. So this is a process that if we wanted to do internet access from the spokes, again, we'd either need to centralize it and build some kind of appliance that would do that for us, or we would need to enable a NAT gateway in each of the VCNs.
Yep.
There's obviously security implications of a NAT gateway, right? It's essentially a big binary internet switch that lets you go out and talk to anything. If you are using Oracle Linux, there are patch repos that you can access through the service gateway as well, which is nice. So if you just want to do like patching of an Oracle Linux box, you don't need a NAT gateway. You can also backhaul that egress traffic on premise and send it out through something, or use like a cloud hosted proxy for something. There's options, essentially.
So I don't want to go too far down a rabbit hole, but I'm just thinking, would it have been possible to attach a NAT gateway in the DMZ and then route from spoke 2 through the DRG through that NAT gateway?
We can try it. Let's remove this. Let's go into the template, and instead of removing it, let's change the VCN.
Oh,
So
I
let's see
what
when
you're
you
saying.
when you create the NAT gateway resource.
And do the DRG, not DRG,
DMZ, and also change the name. .id.
Yep.
And then change both of those. And then you will also need to remove the route, or it'll blow up.
Ah, yes, the route here. You're right. So,
But you
what we'll do
could
is
copy that route, that whole route rule block, and just put it into the DMZ route table.
well here. So it'll still need to go. Oh,
Yeah,
So
you'll need
will
to
it?
change the network entity ID, but that route rule block will be the same. So you can just copy it from here and then delete it, and then put it in the route rule for the DMZ VCN.
Huh. Okay. Let's try that. Because I was wondering if it would route directly to, like, if we rename this, if we left this route here, if it would get the private IP of this NAT
You'd
gateway.
want to just put the default back into the spoke 2 route table to send all traffic through the DRG, and then you would need to add a route
Yes.
in the DRG or in the DMZ subnet to the NAT gateway. So this route rule, I would just copy it and then paste it as a route rule into the DMZ route table. But then before we come back, or before we apply, we're going to want to come back to the route rules for the spoke 2. And we're going to want to put, we're going to want to put that back to default. So, there's a problem. You can't have 2 default routes. So you have a route to the internet gateway, which is 0000 in that DMZ subnet. So you'd need another subnet in the hub VCN to make this work.
Yeah. That's what I was thinking. What I'm thinking may not work because what I was wondering is if you basically it was consolidating traffic so you didn't have to create these NAT gateways in each of the VCNs. I know you can do it if you route it directly to a box like a squid proxy, for example. If you had a squid proxy in your DMZ, you could route traffic directly to it through the DRG, but then you would have to set that up. But I was wondering if I guess how does OCI, what information does this provide? An entity?
Well, so the challenge is, right, we have only one subnet in that DMZ VCN.
Yeah,
and that one subnet has an internet gateway on it, which then means we have to have a default route to the internet gateway. So if you want your Bastion server to continue to work, which we do because we need it, right?
That's right. Yep.
We would need to add another subnet and then make that subnet have a default route to the NAT gateway. And then we would need to look at the DRG route table for that subnet and make sure that things attach in the right way. Like there's a way to do it, but I don't think we basically have to refactor this. That might be something we do next week if we want to see. Because
what I was trying to do, this isn't going to work. This isn't going to work because I'm just wondering what error it'll give me. Because I'm moving the NAT to the public subnet in DMZ, and then telling traffic.
The NAT gateway resource should be fine.
Yeah.
It'll error out on the route. If you add a default route, and it may actually be smart enough to figure out if you do an apply there, it may tell you can't add a NAT gateway, but it's just attaching it to the VCN. So you can absolutely have a NAT gateway and an internet gateway attached to the same VCN. You just can't have a route that points to both of them at the same time.
In that same subnet. That's right. Because that's why you have your traditional 2-stack system has your public subnet, which has its routes are defaulting to the internet gateway, and it has the NAT gateway attached to that subnet, but your private subnet is routed directly to the NAT gateway. So
and again, the reason for that is primarily the internet gateway provides services that you want to expose to the internet. Like in our case, it's the Bastion server, right? We want the Bastion server exposed, but that could just as easily be a load balancer with some containers on the back end, or a load balancer with whatever, right? Some servers on the back end. In order for you to publicly expose a service, you have to have a 1-to-1 NAT ratio of that service and a public IP, and the internet gateway enables that. That traffic is bidirectional, right? So that traffic can come in from the internet or go out to the internet. The NAT gateway is only outbound, but you can't have a route that points to both. Like that's the the downside of a default route is that there can be only one.
Right. Yeah, because that going back to a
And
time
this
when
may fail if the route is still pointing to it.
yeah, a chicken. There may be a chicken egg situation here. But
Yeah, so you'd probably have to, at least in the deploy, and I can't remember honestly in the template if we remove the default route from Spoke 2's VC or subnet.
oh, so I don't think I did. So it's going to take a minute to do that because when what made me think about that, to give context to everyone, is I remember setting up Kubernetes clusters in IP constrained VPCs and AWS VCNs, where you would create like a 100.64 subnet, throw all your containers in it, and then NAT all your traffic through just a subnet that was attached. Oh, yep, here we go. We broke. Anyway, it'd route all your.
So if you just comment out that route table rule from Spoke 02 and redeploy, it should work.
Destination, yeah. So please update parameter stuff on config, because that destination, it doesn't like that. So that's right. Okay, so comment this out. Save that. Let's try this again, because I think you're. That made sense now. You're right. That default, it has two defaults. That's that again. That's why he's the network guy, and I'm the.
It's funny because on my screen it's you is that way. So
oh,
yeah. but that's what it comes down to, right? Is I think it's really important for people to realize that as you get to the cloud, as if you're an enterprise, if you're a small business, if you're a college student that's just starting out, if you're a startup, whatever the case may be, the old way of doing IT was very siloed. You had a server guy, you had a storage guy, you had a network guy, you had gals, women in those roles too, right? It's not just the person. It's the fact that from the standpoint of segmentation, there were very good reasons to have people focus on specific stacks, right? Because you had to go deeper. In storage arrays, you had to create the physical disks, you had to initialize them, you had to format them, create the LUNs, carve them out, allocate them, zone them. You had to do all those things. In the cloud, you don't have to go nearly as deep, but the networking components still touch on premise, right? So you don't have to provision a storage array to get a block disk associated with a VM in the cloud. You just say, I would like one block disk, please, right? So you don't have to go as deep. You don't have to worry about the hypervisor layer when you're provisioning VMs, because the cloud providers take care of that for you. Oracle, AWS, Azure, they all do that, right? So you just don't have to go as deep, but you will have to go broader. You will have to start to be accountable for things. And again, I wasn't a big network guy, but as we got to the cloud, it was a kind of a paradigm shift in terms of, how we were doing business on the daily basis. And we had to adapt, right? I didn't have a choice but to kind of figure out a little bit about how networking works. Now, am I a 400 level networking admin? No, but I'm like 253, right? Like, you don't want to put me in front of a router, but I can work with people that understand those components, and we can usually find a solution. But I don't know the ins and outs of BGP. I just know that it exists, and it is much like sorcery. So we try not to anger the networking gods in that space, but it becomes really important to have a fundamental understanding of how these things work, because if you don't know that you can't have two default routes, then when you go to deploy this, you'll get an error message. You'll be like, well, why not?
So yeah, I think that's what's happening.
Okay, so let's do we need to put that NAT gateway back?
Yeah, let's do that because it worked. I broke it.
So let's remove the route rule. That's gone. That's fine. Leave that out. Let's put the NAT gateway back to what it was.
Okay. Everything's back. Everything's back.
It was still the DMZ VCN though.
It was?
I thought so. There's a little bit of a lag here.
You are correct. Yep. All right. Compartment.
Okay.
Let's see if I broke anything.
Oh,
Probably.
it's all. We'll just have to do destroy. Just forget
Oh,
it ever
oh,
happened.
what happened? Oh, I didn't update. Where did I not update that? Oh, in the route, in the actual route itself. No, I did. Did I save it?
I think it was the
Oh, in the
resource because it's
DMZ.
a default. It's a route table
Yeah,
line 40.
right here. Yep, it was this route rule right here. Oh, that's what broke because I copied that. That
Oh,
was the thing.
haha.
Well,
Hey, he go.
now I'm still
Sorry, I
questioning.
channeled
But
my
we know the other thing worked.
yeah. So let's deploy this and let's get it back to a workable state, right? And again, this is the prime example of why we do iterative designs. We work all this stuff out so that we end up with kind of a cookie cutter template that we can just reuse over and over again.
Yep.
Once we get this working, we can use this same template to deploy a VCN in any region in OCI or multiple VCNs in the same region in OCI, right? And we can attach them to a DRG and we can go down the path of being, sort of infrastructure as code programmatically deployed, which means we have consistency. I've worked in IT a really long time. If Joe builds a storage array, it's going to be different than if Jim builds a storage array. They follow, even if things are manual processes, and well documented from a runbook perspective, there is always drift, right? And somebody comes in and clicks a button, they might not remember to unclick it for testing. So config drift is really bad, and that's why I like this sort of model where we're making iterative changes and then coming up with kind of a gold standard that can be shared. Nobody else has to reinvent that wheel. If you want a VCN, you use this template.
Yep. Yeah, and I mean what we just did is a typical adding a feature to or adding an element to a network topography. Ours was simple, but I mean if you're adding like what we need to do some research, I will do some research on the service gateway aspect. Is like okay, we're gonna add it. We need to make sure we don't break anything, and a lot in this case. You kind of saw the code, the framework, the Terraform framework itself kept me from breaking things too badly. And then we iterate. Okay, that's not. We tried something, doesn't work. One of the things we were talking about last time was it's been a long week. Was the last time where I was speaking with a customer about how do you lay out infrastructure as code like test environments, and it is you spin this up in another test compartment, and we could run this test and then tear everything down after we've validated it as being correct and then apply it to our production so that we don't mess up production while we're playing around with some new feature and some new resource that we're adding. So that's what one cloud gives you. If you did that on-prem, you would have to go off and you would have to purchase double your capacity, purchase double your infrastructure just to test one copy before you applied it to your production. Cloud, just on demand. Spin it up, tear it down, and you're good to go.
Yeah, when
But
people
yeah, we're
ask me
back to a
what the
working
cloud
state.
is,
Just tested it, and now we have gateway natted traffic for that VCN.
yeah, and so to kind of bolt on, Jeremy, to what you were saying, when people ask me what the cloud is, I will usually give them a couple of different answers. One, Linux servers mostly, which is one of my favorite memes. If you look for me on Twitter, you'll likely find that somewhere posted in my profile picture, perhaps. But the other thing is, essentially like the duct tape and baling wire, but someone else's, right? So automation has been done, runbooks have been put together. These are services that have been, sort of honed over time to be sort of self-healing or deployed programmatically, right? It's infrastructure as code, but on a much larger scale. It is also configuration management and configuration drift management from an automation perspective. Because if you're operating at cloud scale, a simple config drift can have dire consequences, like a configuration parameter on one physical server that is different than another could potentially rear its ugly head during an automated patching cycle and cause customer outages. So consistency is really key there. But the real answer that I use to describe what the cloud is essentially the ability to access a nearly unlimited supply of capacity to provision workloads and focus on things that actually matter to you, right? Is there value in managing a hypervisor? No. You get value from the VMs or the containers or the applications that run your workloads. That's what rings your till. So the shift to move to the cloud really kind of is the shift from, sort of a fixed cost model to, hey, let's not be afraid to try something out. We can spin up a whole fleet of servers and do something. And if it works, cool. Then we can make an informed decision, but we don't have to worry about getting cost justification and approval and all that other stuff just to try something. Because you can run 100 a VM for 100 hours with one CPU, or 100 VMs for an hour. Man, I butchered that. I need more coffee. But ultimately, it is just it's a question of, 1,000 CPUs is there and good, and you can access them at any point. Do you want to keep them running? No. Are there best practices that you want to put in place to shut down workloads and scale down when you're done? Absolutely. But you have the power, and it is legitimately the same technology that huge companies use, enterprises use, startups use, Uber uses, right? All of these companies, they're all built on the same stacks. They're all leveraging the same technologies. Hey, fancy. I vamped long enough for Jeremy to test, and it works.
So yeah, so in exactly what we're saying is, and what Creighton said about testing on one VCN and then be able to copy it. So we banged through what it was to get it working on one VCN. We had the other VCN, Spoke One, that now, because we'd figured out the right way we wanted to do it, I was able to transition that code that we learned from one VCN to the other and change some variables, and it now also has public access out, but no public access in. And that's a whole another ball of wax we can talk about later. But we can run secure workloads on these VCNs, and no one can get access to it.
That's the plan.
Yep.
So I think this is really good kind of rehash of what we covered last week, and then also, kind of that iterative deployment model where we continue to build on it. So it sounds like we need to figure out the service gateway thing. So maybe next week we'll show that. And then I don't know, man. I mean, we're going to talk about workloads that get deployed in. Compute is cool, but what are we going to run on it? I think we've talked about maybe kind of focusing on some databasey type stuff, right? That's going to be the source for a lot of that. So, that's going to need the same containers that we've already built. So we built the network, we built some VMs, and we will need to expand our Terraform empire to also include maybe some MySQL or an Oracle database or whatever.
Yeah,
so
we have the network. Now we got to make it work for us. So
exactly.
We might have some friends that'll come along the way and give us and fill in the blanks where we don't exactly know the ins and outs. So we've got to that's where we phone a friend. So,
hey, it's good to have friends.
So with that, so we're back to a working state. Let's do what kind of we opened on. Let me get out of here. So if we do let's get status. Let's see what all. Yep. And so we made changes to this. We're gonna push this so that when my laptop gets blown away in this hurricane that's coming up through the south where I'm at, then Creighton can pick it up where we left off. So I'm just going to do get add get commit.
And again, this code is stuff that we're just kind of playing with. So obviously, I would say probably not production ready, but as we move through this, it definitely may be. You're welcome to take it and use it as a jump start to some of the things that you're doing. But one of the things that I really like about the template that I had that we kind of started merging from is it presents options that can maybe parameterize. Do you want an internet gateway? Do you want a NAT gateway? Do you want a service gateway? So you can use the same template that does not have that stuff sort of rigidly hard coded. So maybe, Jeremy, we look at adding that in a future iteration. So maybe next week we can be like, oh yeah, let's add a NAT gateway to this VCN, and just have that all be controlled by variables.
Yep, that'd be really that makes sense. All right,
Cool.
yeah, let's do that, and then we'll have service gateway and maybe some cool database discussion as well. So
I like it.
So if you're still with us, thank you. I hope you enjoyed it. Tell your friends, and we'll do this again probably next Friday, and we'll make more mistakes and drink more coffee.
Yeah, I appreciate everybody kind of bearing with us. It's something that we are very passionate about, but also not very good at. So as we get better, the quality of the stream should improve. And I'm glad that we didn't record last week, because as we were broadcasting at 60 frames a second, the video was quite choppy. So yeah, improvements. We have made them.
Awesome. All right, Creighton, thank you for assisting me.
Pleasure as always,
been a pleasure.
Jeremy.
And
Thank you, my friend.
Y'all have a
You have
good
a great
weekend
night.
and good night.